Okay, this is Unit 11, Lesson 8. We are solving quadratic equations by graphing now. Okay, so we're going to solve these equations by graphing. And we're going to take the stuff that we learned in the last lesson and actually graph our parabolas and show how that can be used to solve a quadratic function. Okay, now this is the first method, or actually you already learned one method of how to solve a quadratic function. Okay, that was if we had something that looks like this. Okay, and then we would divide by 2 and get x squared equals 18. And then we take the square root of that and say x equals plus or minus the square root of 18. Okay? We wouldn't want to take a quadratic equation like this and solve it by graphing because it's way too easy. So this was the first method we used for easy quadratic equations. But now let's say I get something that looks like this. Okay? Well, it's not going to be very easy for me to solve this because I've got an x squared and an x involved. So all of a sudden I need another method. Graphing is going to be the first method that we're going to teach you to solve one of these. Okay, where we've got an x squared and an x value. So graphing can come in very handy for that. Then after that we're going to teach you another method and then one more later for solving these kinds of equations. Okay, but for now let's focus on the graphing method and how that can help us to solve this. Alright, let's move on. Okay, here are all your steps in order for how we're going to graph a quadratic function. I know there are a lot of them, okay, but they're important. First thing we want to do is write it in this format. Okay, then we're going to pretty much just replace the 0 with a y so we're able to graph it. And we've done that before with some equations. Okay, then step 3, this starts the stuff we did in the last lesson, where we're deciding if the graph opens up or down. Then we're going to find the vertex. Then we're going to go to a table of values, okay? And we'll talk about what this part means. And then we're going to plot some points and connect them with the curve to make our parabola. So that means no straight edges, means we're going to have a curvy shape. And then step 7 says, tell the coordinates where the graph crosses the x-axis. These are the solutions or roots of the equation. Okay, so you got all your steps written here. Get them written down. And then we'll go ahead and move on and teach you how all this goes together. Okay, so right here is an example of a quadratic function where we've got a squared and a single x. So again, we can't really solve this very easily, so one of the methods we're going to use is graphing. Well, first thing we have to do is write it so that we have 0 on a side by itself. So I need to get 0 over here, so I'm going to do that by adding 2 to both sides. Okay, because that makes 0 over here. So I've got negative x squared plus an x, and then I've got plus a 2 added on. Alright, well now what I need to do is take this and write it in graphing format. So I'm going to take this 0 and replace this with a y. Okay, and I'm going to put that out in front of it. So that's going to be the same as y equals. Now again, we need an a value, so I'm going to take this negative and make it negative 1 x squared, plus I need a b value, well this is 1x, plus I've got my constant of 2. So this right here, okay, is the same as this graph. Alright, so I'm going to go ahead and fill that in right here. Y equals negative 1x squared plus 1x plus 2. And first thing I want to do is decide, how does this open? Well, it's going to be opening down because our a is a negative 1. Okay, and the reason why I want to decide that right away is because it's going to help me check to even make sure at the end that my graph could possibly be right. Because if I know that the a is negative and my points ended up going upward, then I did something wrong. And I can try to spot that right away. Okay, next thing we need is the vertex, because that's the center of our graph. Okay, so we're going to find the vertex. And again, the x-coordinate of the vertex is the opposite of b over 2a. So in this case, our x-coordinate is the opposite of b, which is negative 1, all over 2 times my a, which is negative 1. So the x equals negative 1 over 2 times negative 1 is negative 2, which is 1/2. Okay, so the x is 1/2. And now I need to solve for the y. I'm going to solve for the y again by plugging in for my x up here. So I'm going to put negative 1 times my x is 1/2, and I'm squaring that. Okay, I put it in parentheses since it's a fraction. The times we want to use parentheses when we have exponents are if we have fractions or if there's a negative 1/2 that we need to square. Okay, plus we have 1 times 1/2 again, plus 2. So basically all I did is I took my x coordinate I got, my 1/2, and plugged it in for the x's for my function. And I'm going to solve it. Well, 1/2 squared is 1/2 times 1/2. That's 1/4. And 1/4 times negative 1 is negative 1/4. Plus 1 times 1/2 is 1/2. Plus 2. Okay. Well, if I keep moving on here, 1/2 plus 2 is 2.5, and 2/2 minus 1/4 is 2 1/4. So my vertex is at 1/2 and 2 1/4. Okay, now I'm going to throw that right smack in the middle of my table of values here. So I'm going to put that x right here at 1/2. I'm not going to show all the work in the middle because I already did all that. And I'm going to get 2 1/4 over here. Okay, and that's my vertex. Well, now, okay, remember that's going to be my highest point on the graph. I know that's the highest point because it says this opens downward. Now what I want to do is the next step. I'm going to pick points on either side of my vertex here. And to make it a shape that, so that I'm going to be able to tell how the parabola kind of goes together and how quick it rises, I'm going to tell you to put 3 points on both sides. Okay? Well, let's think about a half here. So I want 3 points that are lower than that. But I don't really want to use halves, so I'm going to go to the next whole number underneath a half, which is 0. And then the next whole number, which is negative 1, and then the next one, which is negative 2. And keep them with whole numbers. Same thing here. I'm going to go up from a half to the next whole number, which is 1, and then go to 2, and then go to 3 for my x's. So I'm going to have 7 total points on this graph, and that's what I want. Okay? So now I'm going to plug into my table of values. I've got y equals negative 1 times negative 2 squared, okay, plus 1 times negative 2 plus 2. Now you have to excuse my handwriting because it's really small on here, I know, so I hope you're listening. So I'm going to reread this one more time so you know what to write down. This is negative 1 times my x value squared, so it's negative 2 squared. And I put it in parentheses because I have to square the negative 2. Plus 1 times my x value, which is negative 2, plus 2. Well, now if I solve that out, okay, negative 2 squared is 4, and 4 times negative 1 is negative 4. Okay, negative 4 plus, this makes negative 2, so that's negative 6, and negative 6 plus 2 is negative 4. Now I'm going to go ahead and plug in my negative 1. Negative 1 times negative 1 squared plus 1 times negative 1 plus 2. Negative 1 squared is 1 times negative 1 is negative 1 plus this makes negative 1, so that is negative 2 plus 2 is 0. And now I need to plug in 0. Y equals negative 1 times 0 squared plus 1 times 0 plus 2. Well, 0 squared is 0 times negative 1 is 0 plus 0 plus 2 is 2. Okay? Well, I already did my vertex here, so now I'm going to go down to 1 and plug everything in again. Notice this is a lot of work. Okay? I understand that, but it's all necessary. So now we got negative 1 times 1 squared plus 1 times 1 plus 2. 1 squared is 1 times negative 1. is negative 1. Okay, plus 1 is 0. Plus 2 is 2. Then we got y equals negative 1 times 2 squared plus 1 times my x, which is 2, plus 2. Well, 2 squared is 4 times 1 is negative 4, plus 2 is negative 2, plus 2 is 0. And the last one. And if we plug in 3 for my x's, what I'm going to end up getting is negative 4 if I solve that out. Now look what happens with my table. If I look at my vertex in the middle here and look on either side, look what happens. I got 2, 0, and negative 4. If I go down the table, I got 2, 0, negative 4. And that should happen because I should be symmetrical on both sides of the vertex. Okay? So if these numbers are spaced out evenly from my vertex, so like this one, I went down a half, this one went up a half. Okay, so those are spaced evenly from the vertex. And then I spaced evenly out. I went up 1 and down 1 and up 1 and down 1. Okay, everything's evenly spaced out, so these numbers should be the same. Okay, because it's symmetrical. So now, let's go ahead and plot these points on the next slide. Okay, so I've recopied our table over here, so now what I'm going to do is plot these points. Well, I'm going to go ahead and blow this up a little bit, and I'm going to make each one of these, whoops, sorry. Try that again. Okay, each one of, or every 2 lines is going to be worth 1. Okay, so when I go to negative 2, I'm going negative 1, negative 2, and then down to negative 4. So I'm going all the way down here on this one. So this is negative 2, negative 4, which means that negative 1, 0 is going to be right here. And then 0, 2 is right here. Then I'm going to have 1/2 and 2 1/4. So basically each line here is counting by halves. Okay, so I've got a half and then 1, 2, and about halfway is a 1/4. So about right in there. Then I should be at 1 and 2. And now you can see I'm on my way back down. I've got 2 and 0. And then I should have 3 and negative 4. Now look at your points before you connect them. You should be able to tell this is going to make a U shape right here. So now all I'm going to do is try to connect them to make a smooth U shape that goes through all the points. And there's my rough sketch of a parabola. Now the roots, the solutions, are the x-intercepts. Okay? So I'm going to write this. I got my x-intercepts are at negative 1, 0 and 2, 0. Okay, so I've got negative 1 and 2. So I'm going to write my solutions as x equals negative 1 and 2. Because that's where my graph crosses the x-axis. So basically if I plug in negative 1 and 2 to my original equation, those should work to solve for it. Okay, and again, that's one method for solving quadratics, is by graphing and telling where the roots or the x-intercepts are. Okay, now we'll look at one more example, and we'll go through this one a little quicker as far as filling in the table goes. We'll make sure we have that done already so we don't have to go through and plot everything in and do all the math again. Alright, so let's do one more example.